negative values, it would have taken me a little bit longer. So this is y equals sine x plus the square root of 3 cosine x only between 0 and 2 pi. Yes, solving the trig equations requires time. And luckily here, the second derivative was easy because I got exactly the same solution as before. So I had the positive solutions, I just put them in. Otherwise, I would have needed another 5 minutes to solve that trig equation. Okay, good. Anything else? Is WebAssign finished? Are you completed with that? Everything okay with that? Anyone else needs help with WebAssign? Other topics from here?
I was wondering if we could do an optimization problem.
Very good.
Like the poster.
Good. Very good.
Margins.
Very good. Do you have one in mind?
The one from the homework would suffice.
Yes. So would you remind me? I did not write solutions for the last one. What problem was that? Number?
I can get it. A second.
Was it 42?
Yes.
Okay, very good. So let's take a look on 344. So the area is 180 squared inches. 1 inch margins at the bottom and sides. One, and 2 at the top. And they're all inches. What dimensions will give the largest printed area? So this is the printed area. So we want to maximize, this is not good anymore, maximize printed area. Perfect. Good. So I'm given this area, which is this. So I'm going to denote this by x and this by y. And since we're asked to find the maximum printed area, then I have to determine a function, find a function that represents the printed area. So the area, so I'm going to call this A, is x, but minus 2, and times y, but minus 3. Is this okay so far?
Oh, yes.
Perfect. So I also know that x times y is 180. I will distribute here. See, I didn't put one variable because basically this is 2 variables, x comma y, but we don't need that because we don't know how to differentiate something like this yet. You have to wait till Calc 3. So xy minus 3x minus 2y plus 6. From here, I will solve for y, 180 over x. This will be replaced by 180. This will be replaced by 180 over x. And now, confidently, I can say this will be a function of x, of one variable only. This was 180 plus 6, 186, minus 3x, minus 2 times 180 minus 360 over x. I found my function. So in step number 1, I have a drawing, figure, anything to help me. In step number 2, I created the function. And in step number 3, now I can deal with its max, min, whatever. I have to prove that it's whatever it is, so I don't even care what I'm looking for. I'll find out and I'll prove what it is and move on. So a prime of x, this is 0, this is negative 3, but this 1 over x prime is negative 1 over x squared, so that will change the sign in front, 360 over x squared. Find the least common denominator, negative 3x squared plus 360 over x squared. I need a prime to be 0, only when the top is 0. Of course, I will divide by negative 3. You know me, I'm allergic to negative leading coefficients, and I need to simplify. You cannot divide by x. So this is x squared and minus 120 equals 0. So then x squared equals 120. Please remember, quadratic means 2 solutions. Although one of them is not something that we want to look at. So when I take the square root, I have to write plus or minus. And I have 4 times 30. So this is 2 to the square root of 30 inches. And you'll say, no, only x equals 2 to the square root of 30 inches. What do I know what this gives? I have no clue. I don't know what it gives, but I will in a moment. So what x can be? Of course, it cannot be less than 0. And what x can be is determined by 180. It cannot be any number, right? So I have 2 to the square root of 30. I know that this is a critical number. I like to see what this is. If I find my calculator, it doesn't matter. I have it up here for you. And give me 1 second. I have my computer is dying. So I had to plug it in. Okay, where are you guys? I see you. Okay. So I just want to see what this 2 to the square root of 30 is, approximately. So 10.95. Okay, fine. I was just curious. So approximately 10.95. Okay. So this is the derivative. I will not even discuss the denominator because it's always positive. So when I plug in 0 here, I get a positive number. When I plug in here 100 or whatever, I get a positive number, right? So the solutions are negative and positive. So in between solutions, it's going to be positive. Outside will be negative. Okay, so then I know that this is a maximum. So they're asking us to determine the dimensions that give a maximum printed area. So we found the function that is the printed area, and we found what gives the maximum printed area. So now I have to find y. So it's guaranteed that this as 2 to the square root of 30 inches will give a maximum printed area given this restriction. We are restricted. Now, there cannot be anything. So this is our restriction. Okay, so now I have to find y. But y is 180 over x. So 180 divided by 2 to the square root of 30. I simplify. I rationalize by the square root of 30 and the square root of 30. Simplify. and I get that y equals 3, the square root of 30 inches. And if we want to approximate that, we can. So it's the same thing, but I'll overwrite 2 with 3. Okay, 16.43 inches. Now, if I want to find the maximum area, then I have 186 minus 3 multiplied by x, which, what was our approximation? Okay, that's my x right there, under my nose. 10.95, and then minus 360 divided by 10.95. And this will be in squared inches, so the maximum area, I'm going to put it in as 120.27, approximately, of course, and this is in squared inches of the printed area. But I have to convince myself that this will give a maximum. I don't know. Till I study the sign, I'm not sure. Any questions on this problem?
Thank you.
Thank you. Anything else? Anything else?
Yeah. What's the problem on absolute max mean?
For max min?
Yeah.
On the closed interval, you mean?
On the closed interval, yes.
Good. So one thing I just don't want to forget, page 306. We had several problems all the time like these. Given blah, 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 graph. We also had this in the written homework, so please review. Okay, so let's find, this is in 4.1 on page 387. I'm trying to keep those pages in order so I don't scan them and out of order. Okay, so page 287, max min on a closed interval. Can you refresh my memory if we did this problem? We can choose a different one. I don't remember. It's possible that I selected it before. I let you choose between these two. Or if you want to choose, it's page 287 from 51 through 66. So natural log x squared plus x plus 1 on negative 1, 1. Let me even choose another. Yeah, 59 f of t, t minus the cube root of t from negative 1 to 4. So I can put this book away. Okay, so please choose. This one?
Yeah.
Very, very good. Okay, so of course I'm given negative 1 to 1, f prime, and f of x. There is no discussion there. Luckily, I don't have to find a domain. They are already telling me what to do. So I go ahead directly and find f prime of x, which is 1 over x squared plus x plus 1 times 2x plus 1 in parentheses. And when I set this equal to 0, just the numerator can be 0. So x equals -1/2. Is it in the domain? Yes, it is. Now I study the sign. This will always be positive. How do I know? It's because it's really coming from x cubed minus 1. X cubed minus 1 is x minus 1 times x squared plus x plus 1. This is always positive. But this could be negative and positive. It's a linear function. What would be the sign of a linear function with a positive slope? Negative, positive. Or just plug in numbers. For a closed interval, I have to find the value of the function at -1, of course at the critical number, and of course here. And this has to be a relative min, and I expected it to be an absolute min as well. So I'll plug in the function. Okay, and here it is. Natural log of x squared plus x plus 1. And I plug in -1, -0.5, and 1. Copy, 0 on the left, -0.288 in the middle, and 1.0986. So, as expected, this is the absolute minimum. This is the absolute max, and this is nothing. Absolute minimum and relative minimum. Absolute max, no, not the relative max because it's at the end point of the interval, not relative at the end point ever. But in the middle, yes, it's relative min, absolute min, this number, this point if you want, and this is the absolute max, and this is nothing.
Wait, so is that relative or absolute? This is both.
This is both. -1/2, comma this number is the relative min and the absolute min.
Oh, I did min and max. My bad.
Sorry. Okay, so relative min and absolute min. This one is the absolute max, and it cannot be relative at the endpoint. No endpoint is relative. It's either nothing or some absolute, max or min. Anything else?
Professor, where did the reference to x cubed minus 1 come from in the bottom of the solution?
Oh, I was just explaining, very good question, sorry. I was explaining why and how I know that this is positive. Because it is really an expression that comes from the difference of cubes.
Okay.
And I know that this quantity is always positive forever.
Understood.
The same way if I have the sum. This quantity is still positive. It doesn't have real solutions. But of course, this was just a side comment. This is not part of the solution. Sorry, I didn't mean to confuse anyone.
Oh, no, that's fine. But that just helped you.
Yeah.
You didn't have to actually use the quadratic formula.
I didn't, yes, I didn't exactly.
Okay.
And I didn't have to, basically, I just wanted to explain why this is always positive, and that's why I'm not studying the sign of the derivative.
Okay.
When I say the
That's
sign
very
of the derivative, I'm not looking at this. I'm only looking at this.
I understand. Thank you.
Thank you. So you can quickly check that. So if you go to y equals and clear, and you have, I shouldn't have cleared because it's what I wanted to graph, except in natural log. So x squared plus x and plus 1 you can quickly see that this has a minimum, but it will not cross the x-axis because the solutions are imaginary. So we go to Windows 6 because I had something else in there, and graph. No, I didn't mean that. I want Zoom 6, sorry. So see, it's always positive. And the same thing if I change the middle to negative. So these two quantities, x squared plus x plus 1, maybe you want to remember this. It's you know, as a side issue or side comment. You want to remember that x squared plus x plus 1